channel. Today I am discussing about Byte Pair Encoding Tokenizer. So before I have uploaded introduction to tokenizers, and in that I have mentioned the type of tokenizers we are using. So these tokenizers are very important for the transformer models because those models are complex models, because complex it will understand large sentences, it will identify the underlying distribution and patterns between the each sentences and how they are related. Those complex things, those models will understand. So with the help of tokenizers only, they are able to understand the relation between each words and all those things. So these are very important part of those models. So that's why I want to discuss about all these tokenizers, friends. Let's go into the Byte Pair Encoding Tokenizer. So normally this Byte Pair Encoding Tokenizer we will call as a BPE tokenizer. So it is a subword tokenization, friends. So it means it is a subword tokenization technique. Normally we will use an NLP. Okay, how it will split the words into smaller units. The smaller units we will call as a subwords. So this is a unsupervised learning algorithm. How it works now, it will match most frequent pairs of consecutive bytes. So normally which are repeating more, those will match, friends. That's how this Byte Pair Encoding Tokenizer will work. Okay, so this tokenizer we are using in text classification, machine translation, speech recognition. Okay, so the main advantage is it is suppose if we have out of vocabulary words. Okay, so normally those words means those are not presented in the training data, but those are presented in the testing data, real data. So it can understand better. Okay, so it can understand better, friends. This tokenizer can understand better and can split the words better. Okay, so let's go discuss about the advantages of this tokenizer. Okay, vocabulary size reduction. So it can reduce the vocabulary size and it can handle out of vocabulary words by breaking down complex words into smaller subwords. Okay, that those data is not present in the training data. Okay, so improve model performance. By using subwords, BPE can capture the underlying semantic meaning of complex words. Okay, that may have different variations or inflections. Okay, these are I mentioned. And language agnostic. So we can apply this tokenizer to any language. Does not require any prior knowledge of the language. Okay, let's discuss about the disadvantages, friends. Increased processing time. Because BP require processing the text to learn the subword vocabulary, which can be time consuming because we have to chunk the input sentences into words and which are frequently repeating. We have to, after that we have to match, we have to count which are repeating more, we have to match. So this is a very lot of process are there, right? That's why processing time is more, and computation automatically computational complexity will also more because lot of stuff is there, right? And limited interpretability. Subwords do not always correspond to meaningful linguistic units, making it difficult to, because see, suppose if there is hello world, if we are chunking with the subwords are so which are repeating more, because there is no relevant, most of the times we can't match the relevant occurrences. Okay, that's what, due to this we are unable to interpret the predictions of the model. Okay, it depends upon the count or frequency of that. So I am explaining about the how can we implement this this tokenizer. So I have mentioned step by step. So we have to initialize the vocabulary. Vocabulary means what is the data. Okay, so normally BPE starts with a set of initial tokens, which can be individual character, words, or any other sequence of units. After that we have to count the units. So it will count the frequency of each pair of consecutive units in the training corpus, such as A, B, B, C, C, D, etc. Then we have to merge. So the BPE tokenizer merges the most frequent pair of units into new token and updates the vocabulary. For example, if the most frequent pair is ES, then the tokenizer would merge into a new token called ES and update the vocabulary accordingly. Okay, this is a repetitive process, friends. Okay, and until how much time we can repeat, or so you can define some length, or so up to that you can repeat. So tokenize text. Once the vocabulary has been learned, the BPE tokenizer can be used to tokenize the newly text. Okay. Once all this step done, we can use this tokenizer to tokenize the input words. So let's go into the implementation parts. I have implemented this using TensorFlow and Python. Okay. So I am importing TensorFlow collections and RE. So here is the some description about how each function in the byte pair encoding works. Okay. First, get a stats function. What it will do? It will create a default dict dictionary. Okay. Now I am passing int. Okay. After that, in the vocabulary, I am extracting the data, word and frequency. Okay. So I am splitting the words. Okay. Then I am running a loop with from how much length of these words are there. Okay. -1. Okay. Then I am combining pairs of symbols of this I, what it is there, the index, and I am increasing the index to +1. Okay. And after that I am increasing the frequency if those are repeating. Okay. That's what here you can say. It takes a vocab and returns a dictionary of pairs of consecutive symbols in this case individual characters on the special end of word symbol and their corresponding frequency. Okay. That's what it will do, word and frequency. The function first initializes an empty dictionary. Okay. This is an empty dictionary using collection.default. That's what I mentioned. Then iterates over each word and its frequency in the input vocabulary using this function, friends. Okay. Using vocab.items. Then after splitting all those things happening, then we have to, after we counted how many frequencies happen, then we have to merge, right? That is the second step. So we are defining a function to merge most of frequent pairs. Okay. So this function merge vocabulary takes pair comma v underscore in. Okay. Those two things. Okay. In a pair of symbols, pair and a vocabulary. Okay. And returns a merged vocabulary. That is the output, friends. Okay. So the function first initializes an empty dictionary. So we are initializing empty dictionary as a vword. So that's what we are returning this one as a output. Okay. And it will store it. Then create a regular expression pattern to match the given pair of symbols using re.escape to escape. See here, if there are any special characters, we are escaping using re. After that, that's what I mentioned in this line, special characters in the pair, and join to concat the pair into strings separated by spaces. Okay. The resulting pattern is then compiled into a regular. So we are compiling. Okay. We define some regular expression. Okay. And some special tokens we are adding. Okay. So what this regular expression pattern is constructed to match the given pair of symbols only if it occurs at the beginning of a word or immediately after the white space. Okay. Then this function iterates over each word in the input vocabulary. So it will iterate over each word. Okay. And replaces all the occurrences of the given pair of symbols with a new symbol created by concatenating the symbols using join. Okay. So what it will do, if we are running a loop, whatever presented in the v in, so what we are saying, it will replace the each word with the occurrence of the given pair of symbols. Okay. The sum method of the regular expression object used to replace all occurrence of the pattern with the new symbol. So it will replace, okay, with the new ones. Then the resulting modified word is then added to the new merged vocabulary. So we are adding to the v out. So then we are returning v word. Okay. Then this is our tokenization part. First we have to count the frequency, then we have to merge. So that's what I'm using those two things. So which are most max pairs I'm extracting, then we are merging. Okay. So simple example, this is the corpus. Okay. First what we have to do, we have to get the stats, right? So we are creating a dictionary. So we are running a loop over a corpus. If word present and if for word we are splitting the sentence and we are joining. Okay. then we have to merge. So I define the length 10 only, so it will process the tokenize. Okay, this is, friends, this is all about byte pair encoding. So I hope you guys understand how it works, what are the advantages, disadvantages, and how to implement from the scratch. Okay, this is the implementation from the scratch, friends. Okay, I hope you guys enjoy this video. If you like this video, please click on like button.